Hello friends, welcome you all in my page online chemistry tutor. Today we will discuss about the energy calculation of Bohr atomic model theory. We know that Mr. Bohr have told that the electron is moving around a nucleus in a certain orbit. This is nucleus and this is the orbit where electron is moving, and when the electron is moving in this orbit, the angular momentum of that electron is not arbitrary. The angular momentum value, that is mvr, should be multiplication of h by 2 pi, and this constant value n has come to show the principal quantum number value or the number of the orbit. That is first orbit, this one is second orbit. For this the value of n is 2, this one is third orbit, for this the value of n equal to 3, like that, and so on and so forth. Now we have get the value of r equal to n square h square by 4 pi square m z e square. In our previous video we have shown this value calculation. Now today we will discuss about what is the value of energy of a certain Bohr orbit n. What will be its value? Now we know that the energy is composed of two different energy terms. En equal to potential energy E potential plus E kinetic. Now we have to calculate the value of E potential and E kinetic differentially, and then we will add it. We will go to next page. In this page we will calculate the value of E potential. What will be value of E potential? Now this is nucleus and electron is moving in this orbit. The radius of this orbit is r, and when electron present in infinite distance, this infinite distance, the attractive force will be 0, because we know from Coulomb law that F equal to Q1 Q2 by R square according to CS method, CS unit. As this K value is 1, so this is Q1 Q2 by R square, and when R equal to infinity, then F equal to 0. So at infinity distance the force will be 0, and if force will be 0, the energy will be always equal to 0. So when electron is in infinite distance, the energy is equal to 0, and when this electron comes to this distance, what will be its energy? Its energy will be the energy of the potential energy of electron. Now we have to calculate this one. Now the attractive force is F and the distance is r, so we will bring this energy electron from this infinite distance to this distance r, and this is a very slow process, so we integrate it from infinite distance to r distance, and this is the actual work done by that system. So this is the energy and this is the potential energy. Actually we'll write it E pot. Here the attractive force is Coulomb attractive force, and this is actually Q1 Q2 by r square. The atomic number of this atom is Z, and each proton have a charge of plus E, and the charge of the, so this is a charge of nucleus, and now we write the charge of the electron, that is Q2, that is E, and the distance, that is equal to r square into dr. Now we integrate it from infinity to r. This Z into E, these are constants, so this comes out Z square into 1 by r square dr. Integrate it infinity to r, and we Z get Z square by r minus Z square by r. Now we have to calculate the kinetic energy. We know that kinetic energy E k equal to half a v square. The value of v equal to nh by 2 pi m r, and we know the value of r equal to nh by 2 pi m into 2 pi square. We write it here, n square by 4 pi m z square, sorry, n square a square by 4 pi square m z square, m cut out, 2 pi n square a square nh, we will get 2 pi z square by nh. Okay, this is the value of v. Now we know kinetic energy half m v square, so we write here E k equal to half into m into 4 pi square z square e to the power 4 by n square a square. Okay, so this is equal to half to 2 pi square m z square e to the power 4 by n square a square. Now in the previous slide we also write this value, so minus z square by the value of r is n square by 4 pi square m z square, n square a square by 4 pi square m z square, so we get minus 4 pi square mz square e to the power 4 by n square h square. Okay, so this is the value of kinetic energy and this is the value of potential energy. Now go to previous side. E potential we have get minus 4 pi square mz square e to the power 4 by n square h square, and okay, and here kinetic energy you have get 2 pi square mz square e to the power 4 by n square h square plus 2 pi square mz square e to the power 4 by n square h square. Okay, now we add these two and we get minus 2 pi square mz square e to the power 4 by n square h square, and this is the value of kinetic energy of nth orbit. En equal to minus 2 pi square mz square e to the power 4 by n square h square. Now this is the kinetic and this is the energy of an nth number of orbit of Bohr atomic, according to Bohr atomic model. Thank you for watching this video. Thank you very much.